So, contrary to popular belief, cannabis does not naturally contain any THC. It contains THC acid, and yeah, that's the form that the molecule is present in the cannabis plant. Upon heating, the THC acid gets converted to THC, and this is why people consume cannabis by smoking. If you eat fresh raw bud, you will not get any psychoactive effects. It might still have some other medicinal benefits, but you will not get the psychoactivity that is caused by THC. This is our liquid chromatograph. We use the liquid chromatograph to quantify the different cannabinoids. How it works is the sample goes in the sample rack, so we extract the cannabis with a small amount of solvent. The sample goes in one of these. The rack goes into the auto sampler, and there's a needle in here, a robotic needle, that will automatically pick up the right file, suck up 1 microliter, and inject it into a liquid stream that is generated by these 2 pumps. The pumps will pump then the sample into this column, and in the column the different cannabinoids will separate and elute at different times at the back end of the column, and are then detected by the diode array detector that we use. And the amount of response from the detector is proportional to the amount of cannabinoid that's present. So when you measure with liquid chromatography, you need to correct for the weight loss that will happen when CO2 dissipates upon heating of the THC acid. So we recently seen a lot of reports by other labs that report values of THC above 25%, sometimes up to 35%. These numbers are extremely high and cannot be accurate, because 1/3 of the plant material in that case would have to be resin. So basically you would have a glob, instead of plant material, you would have a glob of sticky resin. So what we figured out is that a lot of the labs are actually doing their calculations the wrong way. They do not correct for the fact that when you convert THC acid into THC, you lose a lot of weight.
So it's important to understand how different labs could offer different laboratory values, or quote-unquote answers to the concentration of THC or cannabinoids inside the product. The plant's natural product, tetrahydrocannabinolic acid, contains the carboxylic acid functional group here, which upon heating eliminates CO2 and provides the molecule of THC. You'll notice their molecular weights are different. One weighs a lot more than the other one. If I take 10 molecules of each one and set it on the balance, I'll have more weight of THCA than THC. It's important to understand those differences and consider the molecular weight when you are reporting results by weight. So results are reported by weight percent, and we use the math that is shown here to do so. It takes into account the molecular weight of THCA and the molecular weight of THC, and uses the algebraic equation to take the amount of THC naturally present upon curing, heating, or storage in the room, plus the THCA that is formed by the plant, to come up with the total maximum value according to this equation here. If a laboratory is simply summing up the 2 numbers, it tells you that they are not possessing a strong command of the math and science behind the scenes to be providing you with accurate results.
I'm weighing some cannabis in these test tubes now, and we're gonna put a balloon on one of these test tubes, and we'll show that when THC decarboxylates, that CO2 forms, because the THC acid releases CO2 and turns into THC, which is the active psychoactive component in cannabis. We now have a test tube full of cannabis, and we're gonna put a balloon here on top. I'll show you. Okay. So here we have a test tube with a balloon, and the test tube is filled with cannabis, and we'll see, and we'll show that CO2 forms when it gets heated. The THC acid will slowly convert to THC, and CO2 gas will be released. And this one we're gonna put on a cap with a hole, and then we have a CO2 sensor that fits right into here. So this sensor is sensitive for CO2, very selective, so it will respond to the amount of CO2 that's in the air that's in the tube. So that way we can prove that CO2 is actually generated when cannabis decarboxylates. So when the THC acid turns into THC, CO2 will form, and the sensor will detect that, and we can read that off of the display here, and also the computer locks it every second, so we can draw a nice graph afterwards.
We've been told time and time again by numerous clients that they give us the same sample with different names to try and blind test us, and we come back with the same results, which is good. Other labs have been tested the same way, and we are told that they don't come back with the same values. There is a lot of variability out there, which I think is part of the marvelous part of cannabis and the great part about allowing a lot of the people to cultivate it in different ways. We don't know what's going to be that next best medicinal strain. We don't know what's going to have the best effects for certain people. What happens when we stop breeding THC in, breed it out, and breed all the other cannabinoids at high levels? What might we find then? So to me, it's like an endless fascination with what we may utilize this plant in all of its forms, raw on the flower, into concentrates, into every possible edible product that we've seen here. I think the diversity and variability is one thing that we could have never quite anticipated, but are exceptionally happy to find.
If you don't correct for this amount, you get it's not flowing.